Black holes are regions in space where gravity is so intense that nothing, not even light, can escape. They are the remnants of massive stars that collapsed under their own gravity. Contrary to popular myth, black holes don't suck like cosmic vacuum cleaners. Objects fall in only if they cross the event horizon, a boundary defined by the black hole's mass and size. The Schwarzschild radius formula, Rs equals 2 gm over c squared, defines this boundary. For a 10 solar mass black hole, this radius is approximately 30 kilometers. White holes, however, are their theoretical opposites. Predicted by solutions to Einstein's equations, they eject matter and energy but cannot be entered. Unlike black holes, which trap everything inside, white holes are cosmic fountains, existing only in theory so far. So, what if a black hole and a white hole were to meet? Some physicists suggest such an interaction could create a wormhole. This wormhole would be a tunnel connecting 2 points in spacetime. Matter entering the black hole might emerge from the white hole elsewhere in the universe, potentially instantly. But this is where physics gets extreme. Black holes exert enormous tidal forces, stretching and compressing any approaching object. This phenomenon, called spaghettification, is particularly intense near stellar mass black holes. For supermassive black holes, the effect is weaker near the horizon, but the energies involved are staggering. White holes, being highly unstable, could collapse instantly if disturbed. The intense gravitational field of a black hole could destabilize a white hole. This destabilization would release an enormous burst of energy, potentially rivaling or exceeding a supernova. This event would produce gravitational waves and gamma-ray bursts. Mathematically, black hole-white hole pairs are described in general relativity, but no such objects have been observed. Theoretically, the black hole's mass and spin would dictate the dynamics of the encounter. Rapid rotation could twist spacetime, possibly forming a rotating wormhole, also called a Kerr wormhole. If such an event occurred in our universe, the consequences would be profound. Nearby stars could be ejected from their orbits. Intense radiation could sterilize planets nearby, and gravitational waves would ripple across galaxies, potentially detectable by observatories like LIGO or Virgo. LIGO, the Laser Interferometer Gravitational Wave Observatory, is designed to detect these ripples in space-time, providing crucial insights into extreme cosmic events. It's also possible that the encounter would simply destroy the white hole, leaving only the black hole behind, consuming the matter it ejects. Or, if a wormhole forms, it could exist only briefly before collapsing under quantum instabilities, according to current theories. Black holes and white holes remind us of the universe's extremes, where gravity bends space-time and the laws of physics are pushed to their limits. While white holes remain theoretical, imagining their encounter with black holes stretches our understanding of reality itself. The cosmos is stranger, more violent, and more beautiful than we can imagine, and the mysteries of black holes and white holes are far from solved.